Okay, next step are zeros, which are going to be your x-intercepts. This is where you focus solely on the numerator. So whenever you're going to look for the x-intercepts, we're just going to focus on the top of the equation. And again, not only are there end behaviors with vertical asymptotes like the previous section, there are also end behaviors for the or not end behaviors, but behaviors around the zeros. And I'll show you what that means in a few minutes. There's going to be 3 behaviors around the zeros. It's going to pass straight through the x-axis if the exponent of the numerator binomial is 1. It is going to be tangent if the exponent of the numerator binomial is 2. And it's going to be concave if the exponent of the numerator binomial is 3. So let's go ahead and find the x-intercepts just by taking a look at these two. And then we'll go ahead and determine the behavior. So to find the x-intercept for the first one right here, go ahead and solve for x. Your x-intercept is going to be a -1, 0. Remember, this has a degree of 1, so this is going to have straight behavior. And again, just like when I labeled the vertical asymptotes opposite and same, when I go and solve for my x-intercepts when I'm graphing rational functions, I label the behavior in my work here also. So since this has straight behavior, I'm going to put a little s here to remind myself that I have to sketch this according to the behavior around the x-axis. The next thing that we're going to look at is the other x-intercept. And this is x plus 3. Set it equal to 0. Solve for x. So we know that your x-intercept is going to be a -3, 0. And this 2 is going to have straight behavior because this has an exponent of 1. All right, so now we're going to move on and go to our next step in getting all of our pieces for our puzzle into graphing a rational function.